So just to define it, series, sorry, I want to change this up a little bit, the angle. Is the sum of the terms of a sequence. It's an arithmetic series if the terms of a sequence have a common difference. And what that means is they increase or decrease linearly. So that idea that if it's like has a common growth or a slope, so some of this is kind of jumping ahead to what we'll do in the classwork today. So we know that CPM kind of has you discover stuff. Some of it I'm just kind of telling you up front, and it might make it go a little bit quicker. So if the sequence is in the form T of n equals mn plus b. So it's just like y equals mx plus b, but remember we use T of n, and then that means n here and not x. So if this is the case, I'll just define all of these. M would be the common difference. Or the growth. N is the term number. So, you know, is it the first thing in the list, the second thing in the list, the third thing, etc. And then B is that 0th term or the starting point. But we should know a 0th term doesn't actually exist for a sequence or a series, because it doesn't, the sequence starts with the first thing in the list, then there's a second thing. So this we have to work backwards to find. So if this is the sequence in this form, T of n equals mn plus b, then the series is T of 1 plus T of 2 plus T of 3 plus ... all the way to T of k for k terms. And this will make more sense when we have numbers, but basically plug in 1, plug in 2, plug in 3, all the way to k, whatever that last term is. It could be 12, it could be 27, but it has to be a whole positive number. And so the sum of all these terms, and this is what we were doing last week with the rectangle, is the number of terms divided by 2. So that was like when we had the stairs, remember we cut it in the bottom in half. So we would take half of the terms in the bottom and then we multiply that by the first term plus the last term. And so, again, that goes back to this this rectangle, this idea of the stairs. Remember, we had 6 steps here. When we cut it in half, it was 3 wide. And so that's the number of terms divided by 2. And then we took the height of the first stair and added the height of the last stair to get the height of the rectangle. So that's kind of what this means right here. So we'll do some examples. Find the sums. So A, I'm going to tell you T of 1 equals -3. T of n equals 15. And n equals 10. I'll just write out, we're going to do 3 of these. So B is going to be 12 plus 21 plus 30 plus ... And I'm going to tell you that n is equal to 8. And C, T of 1 equals -7. D equals -6. And n equals 13. So you can see all of these look a little bit different. So on this, on part A, when it's T of 1, that means that's your first term. And T of n, that's going to be your last term. And n here will be the number of terms. So our first term is -3, our last term is 15, and we have 10 terms. So if we have stairs, that's kind of, there would be 10 of them. This is weird because it would be negative, and then that last one would be 15. So our sum here, if we just kind of plug into that, the number of terms is 10 divided by 2 times the first term is -3 plus 15. We don't have to list out every single one. We don't have to figure out how much it's growing by. They just want to know the sum. So 10 divided by 2 is 5, -3 plus 15 is 12. 5 times 12 is 60. So for part B here, we don't know the last term. We know that there's 8 terms and we know the first term, but we don't know the last term. Sure, we could list all of them out if we wanted to, but nobody really wants to do that. Especially for 8, it's not that bad, but if this was a bigger number, that's just going to be kind of a lot of wasted time to list them all. So we can see what the growth is, or the common difference. We can see that this is adding 9 every time. Which meant there had to be a term back here that 0th term that if we would have added 9 to, we would have gotten 12. So this tells us that our 0th term would be 3. So we could write this in sequence form, just kind of the generator here, as t of n equals 9n plus 3. It's growing by 9, and then the 0th term would be 3. So we know for our sum that it's going to be 8 divided by 2, the number of terms, there's 8 of them, times the first term plus whatever the last term is, and we have to find that last term. So to find the last term, if we know there's 8 terms, we're going to plug in 8. So if I want to find t of 8, this is going to be the last term. Again, we know there's 8 terms, plugging in 8 will give us that last term. So t of 8 is 9 times 8 plus 3. We know 9 times 8 is 72, plus 3 would give us 75. So our sum is 8 divided by 2 times 12 plus 75. Half of 8 is 4. Adding those, I get 87. 4 times 87 is going to be 348. So on part C then, the first term is -7. D, this is the common difference. That's going to be the letter that they use for common difference. And then N is, again, that's the number of terms. So let's see. I know, like, if I were to write out the sequence, listing them, not this series, my first term would be -7. Then I would subtract 6 because that's what it's growing by. I'd get -13, -19, ... Again, this is subtracting 6 every time. So that tells me my 0th term would have been -1. Working the other way, if I added 6, I would have -1 there. So my sequence generator is t of n is -6n minus 1. So same thing, I want to find my last term, t of 13, so -6 times 13 minus 1. I'm going to end up with -79. So that's my last term. So my sum is 13 divided by 2 times my first term is -7 minus 79. So this still works the same way, even with the stairs. The idea with the stairs is if there were an odd number, you would just cut one of them in half. So this is 6.5 times -86, which is -559. All right, and then we're going to do one more example that's just a little bit different. We're going to find the number of terms. So I'm going to say t of 1 is 23. T of n is 163, and S of n, so the sum of the first n terms, is 1,395. So we know the first term, we know the last term, and we know the sum. Again, first term, last term, sum. So if I just use this equation here, 1,395 is the sum, is equal to the number of terms divided by 2. I don't know the number of terms. I'm going to call it n divided by 2 times the first term is 23 plus the last term is 163. And remember, I said this at the beginning, but n must be a whole number. So no decimals, no negatives. N has to be a whole number because it's how many terms are you adding together. That's kind of what this is asking. So 1395 equals n over 2 times 186. You have a couple of options here. I'm just going to take half of 186. 1395 equals 93n, and n is equal to 15. Okay, so here on 24, it says it's talking about Antonio's method. Ignore that, but that's basically the idea of using the stairs. But like I said, we just went over kind of the formula here. So I want you guys to try 24. I'm going to give you, I don't know, 2 or 3 minutes. See what you can figure out. So you just want to find the sum of each of these. They're similar to our examples. See where you're getting stuck. Maybe it's super easy for you. Maybe it's a little tricky. Maybe you can do part of it. And if you're getting stuck, what part are you getting stuck on? So take a minute, see if you can just find the sum of each of those, A, B, and C. And if you have questions, you can type them in the chat, or you can kind of ask me after, whatever works best. Okay, so I'm going to go maybe a little bit quicker than I did on the notes. I think B is probably the easiest one here because they give you everything you need. They give you the first term, they tell you there's 14 terms, and then they give you the 14th term, which means that that's the last term. So on part B, the sum is equal to 14 divided by 2 times 8 plus 151. So this is 7 times 159. So on B, it's 1,113. A is a little bit trickier. So let's actually do C, I think. So C, they tell you how to get the terms, and they tell you how many terms there are. So we know the 3 pieces of information we need to find the sum is how many terms there are, the first term and the last term. So we just have to find the first and the last term here so that we can find our sum. So T of 1 is going to be 6 times 1 minus 2, which is going to give us 4. And T of 25 is 6 times 25 minus 2, which is going to be 148. So again, they told us how many terms there were. We needed the first term, so I plugged in 1. We needed the last term, so I plugged in 25. So the sum, sometimes it's written like this, S of 25, meaning the sum of the first 25 terms is going to be 25 divided by 2 times 4 plus 148. Half of 25 is 12.5 times 152. So our sum here is 1900. So A is, like I said, a little bit trickier. There's a couple of different ways to approach this problem. We know the first term is 11. We know the last term is 74. What we don't know is how many terms there are. So you have a few ways to find it. You can do, we could list all of the terms out because we can tell that it's adding 7 every time. Personally, I think that's a little bit more work, but you're welcome to do it that way. And if that's how you're going to get the right answer, then go ahead and do it that way. There's more than one way to do this. So like I said, I'm going to we know that the sum is something divided by 2 times 11 plus 74. We just don't know what that something is. We don't know how many steps this would have or how many terms there are in here. So that's what we need to find. So if I think about what this would look like written as a sequence, T of n, I can tell that it's growing by 7, 11, 18, 25. So my growth is 7. So 7n plus, remember it's not 11. You have to work backwards to find your 0th term. So my 0th term would have been 4. If you have questions on where I got these numbers, please let me know. So the reason I did this is I want to know what term number 74 is, because that's my last term and that'll tell me how many terms are in this sequence. So if I want to know what term number it is, I'm going to do 74 equals 7n plus 4. I'm plugging that in for T of n. So that tells me 70 equals 7n, or n equals 10. So this tells me that this is the 10th term, which means this is going to be 10 divided by 2 there. So this is then 5 times 85, which is 425. So sometimes you have to figure out how many terms there are by using the sequence generator here, this equation. Okay, questions? All right, so this 25 says, remember Angela from problem 10-1. Her uncle Zachary started by depositing $50, then each month deposited an amount that was $3 more than the previous month. He gave all of the money to her for college on her 18th birthday. Using these strategies and that we just went over, we want to know how much money Uncle Zachary gave to Angela on her 18th birthday. So we want to know on her 18th birthday, how much money she got. And just to kind of refresh your memory, This was problem number 1. The first month he gave her $50, then $53, then $56, then $59. On her first birthday, after 12 months, 1 year, he gave her $83. And we came up with this equation. T of n equals 3n plus 47. So on this problem, basically we're saying we want to know 50 plus 53 plus 56 plus all the way until her 18th birthday. And she gets money every month. So T of n we know is 3n plus 47. It's growing by 3, and our 0th term would have been 47. So the sum here, n divided by 2 times 50 plus something. So I don't know how much money she gets for that last deposit, and I don't know how many deposits were made. So I want to know on her 18th birthday, how many deposits is that going to be on her 18th birthday if he gives her money that last time for her 18th birthday? So remember, he's giving her money every month up until she turns 18. So this isn't going to be 18. This is going to be 216. So he's going to make 216 total deposits. 216 comes from 12 times 18. 12 deposits per year for 18 years. So this will be 216 here. So that's the number of terms. We still don't know the last term. So we have to find that last term by plugging in 216. So 648 plus 47. So that last deposit is going to be $695. So the sum here is 108 times 745. So that's a total of $80,000, $80,460. Again, we knew it was growing by 3 every month. We knew that this was our sequence generator. So we had to figure out that there were 216 deposits or months because 12 deposits per year for 18 years. So we had to figure out the last one was 695, and then we could use our formula. So 10-26, decide whether each situation below involves a series or a sequence and give a reason, then answer the question. So remember, series, are you listing them? Sequence, are you adding them? So on A, it says hornets build nests by constructing hexagonal cells around a center as shown at right. As this hexagonal pattern forms, the first ring of cells has 6 cells, then the next has 12 cells, then the next has 18. If a colony of hornets builds 10 rings, how many cells will they have in all? So is this a series or a sequence? Please let me know what you think in the chat. So series, adding all the terms, or sequence, listing all of them. We want to know how many cells will they have in all 10 rings. Okay, I'm gonna wait for a few. And if you're not sure, you can tell me you're not sure. Maybe you don't know the difference. Getting a few more responses here. I'm gonna wait for a handful more. Okay, so yes, A is a series. Most of you said that. A few of you were unsure, and that's okay. But basically, think of what's going on here. So they add 6, then the next ring adds 12, then the next one's going to add 18, and we're going to add 10 rings total. And they want to know how many cells will they have in all 10 rings. So you're going to add all of them up. So it's a series. So basically we know it's 6 plus 12 plus 18 plus ... And we know n is equal to 10. So same idea, we could list all 10 to figure out what the last one is, or we could write the sequence generator, the T of n, to figure out so T of n equals 6n. And my 0th term would actually be 0. So this is just 6n, because if I worked backwards and subtracted 6, it would be 0. So then T of 10 is 60. That 10th ring is going to have 60 cells. So my sum here, 10 rings, cut that in half. First ring had 6 cells, and the 10th ring has 60. So 5 times 66 is going to be 330. All right, B. Again, we're determining if it's a series or a sequence first. Thanks to fundraising, the balance of the math club savings account grows by $55 each month. The balance at the end of the first month of the school year is $190.